Hey everyone, hope everyone's having a really good time this week in San Francisco at Red Hat Summit. Everybody doing okay? Okay, so my name is John Benedict and I'm here with Jason Tower and Jeff Spahr, and we're going to talk to you today about powering bandwidth with Red Hat, specifically how they deployed OpenShift on Red Hat Virtualization. And we have a very short agenda. We're going to go into a little bit of an introduction and some background. These guys are going to talk to you about some of the problems that they were trying to address when they deployed OpenShift on bandwidth, and hopefully we're going to leave some time for some Q&A and get some interaction with you guys. And so let's start off with a little bit of an introduction. So, guys, you want to introduce yourselves?
Hi, my name is Jason Tower. I'm a senior systems engineer at Bandwidth. I'm sorry, I forgot to get center in the video. I'm Jason Tower. I'm the senior systems engineer at Bandwidth. I am primarily responsible for our Rev and our OpenShift infrastructure.
And I'm Jeff Spahr. I lead the systems infrastructure team at Bandwidth, and Red Hat Virtualization and OpenShift are part of those responsibilities.
Cool. And I'm John Benedict again, and I handle technical marketing and technical evangelism for Red Hat Virtualization. So if you guys want to be a little respectful, laptops down, cell phones to vibrate.
Yeah, please. Actually, we're just kidding. Everybody, please get out your cell phones and open up your text messaging app. We're going to do a little test here. You're going to help me out.
Seriously, pull them out.
Yeah, not kidding. Everyone, get out your phones. You're not going to get very many presenters who say that. So let's take advantage of it. Now, hopefully, is everyone able to see that phone number in the top right corner? 984-444-8392. If you would be so kind as to send a simple text message to that phone number. It'll only cost you, I'm pretty sure it's no more than $15. And keep your eye on the screen, of course, as that happens. You have pins dropping from all over the place. Pretty good representative sample. Now we can scroll around and see who has the best sense of humor. Because if I push my luck too far, I'll probably get one that I don't want to be recorded. Anyway, just a little example of what we do at Bandwidth. What do we just see? This is one of Bandwidth core applications that was developed, containerized, and run on Red Hat OpenShift container platform on top of Rev. So something that one of our developers, Hayden, stand up, give a quick wave, put together in the past week or so, and we just wanted to give a chance to show kind of the sort of things that Bandwidth does with relation to the telco world. We can take phone calls, take in messages, translate them, do all sorts of interesting, transformative things. In this case, put them on a map and show where everybody's from. So thank you very much for that. We actually do normally run this on our in-house infrastructure. For the purposes of this demonstration, you may have noticed that it's actually running on a hosted OpenShift platform. That's just for some security regulatory concerns, plus the fact that we don't have to have a VPN, and we all know that the networking gods don't always do so well at demos, so we wanted to keep things simple. But this was entirely developed in-house and on our OpenShift cluster running on top of Rev.
So anybody already running OpenShift? Anybody already running Rev? Anybody already running OpenShift on Rev? Okay, that's okay. So for those of you not familiar with OpenShift, OpenShift Container Platform, in short, this is a container platform built on Kubernetes, on Docker, using Red Hat Enterprise Linux, provides that trusted container platform, the container orchestration, as well as all of the developer tools that you would want to use to provide that continuous integration and continuous development environment. Red Hat Virtualization, on the other hand, is a software-defined platform used to virtualize both Linux and Windows workloads. It's very easy to operationalize. It's very easy to automate. Provides the means to balance out your workloads for for utilization, for distributing workloads, and it's used to or designed to optimize for current workloads, traditional virtualization, as well as those workloads for tomorrow, so such as containerized applications. So what does Bandwidth do?
So Bandwidth is a leader in the communication platform as a service space. We provide voice messaging and 911 services. One of our mission statements is to grind telecom into software, you don't have to understand the complexities of the telco infrastructure, just use RESTful APIs to make phone calls and send messages. So what problems were we trying to solve when we implemented OpenShift? Well, one of them, we wanted to provide an abstraction to infrastructure. Think about what that means for being able to deploy the same way to a public cloud or your on-premises infrastructure or even your laptop. We wanted infrastructure automation, so we wanted to get out of the ticketing business for VMs, storage, load balancers, all that stuff. Deployment team autonomy. We wanted whatever team was responsible for deploying an application to we'll set them up with a project and some quotas, and from there they kind of own their own destiny. Infrastructure as code is important, allows us to kind of see revision control history of changes we've made, helps prevent configuration drift, those sorts of things. For security, in the VM world or traditional server world, you get stuck in having to patch, do yum updates for the entire life cycle of that VM. With kind of the immutable container world, if you're already deploying your application every week, you just deploy on the latest image, and you kind of get out of that world. And then we also wanted to enable some more complex mature deployment strategies like blue-green, canary, get easy rollbacks, and be able to auto-scale, those sorts of things. So why did we choose containers? There's a ton of buzzwords around, immutable, lightweight, boot fast, and all those things are really important, but really it's just kind of an implementation detail for us. This got really interesting once the container orchestration space started heating up, and then we really saw, oh yeah, this really will solve some real problems for us. We chose OpenShift. Well, for one, we wanted, it was pretty clear that Kubernetes was the winner in the container orchestration space. So we went forward with Kubernetes. Red Hat's a leader in the Kubernetes ecosystem. We wanted vendor support. It's has a lot of complexities that go in Kubernetes. It's new, we're learning, wanted an expert to call when we needed to. Fits our ecosystem well. We're already using other Red Hat products. We already have a relationship with them. And OpenShift fills some of the enterprise gaps that we'd have to solve by ourselves if we went a vanilla Kubernetes kind of deployment route. Why did we choose Rev? It's a fully featured virtualization platform. We really like the subscription model that includes all available features. You don't have to, buy licenses and the tier you can afford, and those are the features you get. It's open source. The feature velocity for it has been great. I've been using Rev since the 2.2 days, and that platform has evolved a lot since then. And cost was also a factor. So how do we deploy OpenShift on Rev? So all of our master, all of our infrastructure nodes, those are VMs. And many of our application nodes are VMs as well. When we get to a certain capacity threshold, we start moving our application nodes over to bare metal, just so we don't have big VMs that are the same size as our hypervisor. And then also public cloud, so we can do either rapid or kind of unknown capacity needs. Great for POCs, that kind of stuff as well. And why don't we do bare metal for everything? Because it's kind of a pain. Our VM deployment process is pretty mature, pretty well automated. VMs are quick and easy. Bare metal has procurement lead times. You actually have to rack and stack it, cable it, install an OS on it, and you may not have invested as much time automating all of that stuff if you're primarily a VM environment. But it did make sense for us as a capacity play. But you guys, you should use whatever infrastructure and tools you're familiar with. So, if you're primarily deploying everything on your virtualization infrastructure, keep doing that. If you're a public cloud user, then deploy the stuff on EC2 or whatever you're using. And just, adjust that decision as your process evolves and as you, run into reasons why you might want to do something different.
Thanks, Jeff. Before we get into lessons learned, I'd like to do kind of the first half of the second demo, just because there's a small delay in getting some of the workload done. So what I'm going to do here real quick is I'm going to log in to our OpenShift environment, and we're using this particular application that we're seeing is called CatMap. Our internal application is called Catapult, and this maps it, so hence CatMap. Nothing to do with cats.
Or cheeseburgers.
All right, so we're logged in. I've gone into my directory, which contains the Git repository. I'm going to do a pull and a check out of the appropriate branch just to make sure we're all in the right place. And what I'm going to do is I'm going to edit that little corner of text in the top because I forgot to say please. Mom, I hope you're not watching. All right, so we're going to save that change. And just to save time, I'm going to do 3 commands all at once. We're going to do a git add, a git commit, and a git push. Now, as soon as that happens, we are also logged in to our OpenShift web console. I'm going to go look at our build, and you'll see we have just that git commit and git push has kicked off a build. This will take about 2.5 minutes to run, so I'm going to let this run in the background. But before I do, just real quick, I'm going to go over and look at our application pod. This pod right here, this CatMap latest 18, that's the one we're actually running. That's the application that we're seeing, and we can see that here. All right, so let me go back. We're going to let this grind away for a little while, and we'll come back to that. Okay, so lessons learned. On the infrastructure side, one thing you want to do is you really want to use anti-affinity groups to ensure that your various OpenShift nodes are not running on the same hypervisor. Sort of this thing where they have where the president and the vice president aren't supposed to fly in the same plane, kind of the same idea. Typical OpenShift installation will usually have master nodes, infrastructure nodes, and application nodes. Typically 3 of each, with more application nodes as required is kind of a standard way to get started. So you'll use anti-affinity nodes to ensure that your master 1, master 2, master 3 are never running on the same hypervisor. You want to keep them separated. You also want to keep a close eye on resource utilization on your application nodes. Your master and infrastructure nodes are generally going to be controlled by your system administration team. Their load isn't all that variable. That's where your etcd runs, that's where your router pods, maybe some back-end logging and metrics, but that's all fairly well constrained and doesn't vary that much over time. However, your application load can vary wildly. So you want to keep an eye on your application nodes to make sure that they don't spiral out of control. You want to configure your VMs to be highly available. Now, fortunately, OpenShift is relatively resilient when it comes to staying available even if a master or an infrastructure node or an app node should become unavailable. That being said, you certainly don't want to encourage that behavior. So within the Rev environment, you want to make sure that your OpenShift nodes are designed for high availability. They will auto-migrate from one hypervisor to another if there's a load issue, that kind of thing. And lastly, you want to take special care of etcd. etcd is the brains of the organization when it comes to OpenShift. etcd is what defines the state of your cluster. You can lose almost every other component of OpenShift and bring it back from the dead or rebuild it from scratch, and your cluster will end up in the same state as it was before that component died. Lose etcd, however, and it's a different story. So it's very important that you take care of your etcd nodes. On the application side, we learned a few lessons here as well. One of the things that we do is we allow our lab clusters, we allow users to self-provision projects. That means that they can log in, request a project, get resources, and get to work without any administrator intervention whatsoever. So as with a lot of things, there are pros and cons to this. It means that we don't have to do any additional work. They don't have to do any additional waiting. So it really speeds up their development cycle. The downside, of course, is that give someone an inch and they take a mile. So it's very possible for users to request 1, 2, 10, 100 different projects, each of which does consume resources. So you need to make sure that people are generally respectful of that. We do not do this in production, however. In production, we turn off the self-provisioning. We literally remove the self-provisioning role from end users. So they cannot request their own projects. They cannot run code on there without intervention, administrator intervention. We do this specifically so that we can keep close tabs on resource utilization, make sure that we have limits and quotas set up, the correct ACLs and all of that. So we have a different environment from that aspect between lab and production. However, beyond that, our lab and production environments are basically identical. So code that is deployed in the lab can get deployed in production with absolutely no changes whatsoever. As I mentioned, quotas are the key to capacity management. As you're using OpenShift or getting started with it, take the time to get to know limits and requests. This is what both makes resources available on a guaranteed level and gives you your burstability when you need additional resources on a short-term basis. I'm not going to get into all the details now, but definitely take the time to research limits and quotas and requests and limits and understand how they play together and make your cluster as available as possible and make the most resources available to users without causing any performance problems. Finally, we learned that TCP and HTTP are first-class citizens within the OpenShift infrastructure. It's designed around these two protocols. Of course, obviously HTTP is layered on top of TCP, but it's really designed for web applications, RESTful interfaces, things like that. Once you go off the reservation and start trying to do other things, like for instance, Bandwidth is largely a voice company. We do a lot with SIP traffic. That generally runs on UDP. Getting that traffic into OpenShift has required a bit more effort on our part. We're not entirely satisfied with where we are in that, so work is ongoing in conjunction with Red Hat. But using non-HTTP or non-TCP protocols does provide an additional challenge that you will have to work out.
So, one of the things that I wanted to point out when you're talking about on-premise infrastructure for OpenShift, we have three choices here. We have bare metal, we have virtualization, and we have private cloud OpenShift, if you will. All of these are really good choices, but it really comes down to how do you make that selection and how do you prioritize the characteristics of the workload and your deployment options. So, for instance, when you look at something like OpenStack, it's fantastic for those distributed workloads, those microservices, and things like that. But if you don't already have a need for those distributed workloads, those microservices, then it can be a heavy lift for a lot of folks. But if you already have that need, or if you already have OpenShift in your environment, then absolutely you can deploy OpenShift there. It's not a problem. It will support it. It'll be a great infrastructure. On the other hand, if you need the absolute highest density for your application, for the entire infrastructure, or if you have applications that have the highest sensitivity to things like network latency and disk latency, then bare metal is really going to take very good care of you there. But if those aren't your highest priorities, then bare metal doesn't necessarily buy you a whole lot more than that. And that's why virtualization, specifically Red Hat Virtualization, kind of sits in the middle of providing great performance, but also providing you with a lot of great options from an automation standpoint. So the other thing that I want to emphasize here, and this is what Jeff and Jason were talking about, is the fact that the same team that can manage and operationalize Red Hat Virtualization can also manage and administer OpenShift Container Platform. And a lot of that has to do with the tools that are used and the tools that are used to manage, the tools that are used to integrate, the tools that are used to keep it all together. So additional security layers. So OpenShift Container Platform, it's built on RHEL. Trusted containers are built on RHEL. If you're using a trusted registry, that's providing security. So we're not talking about, oh my gosh, you have to use Rev in order to have security. This is just an additional security layer by way of discrete kernels for each of the individual virtual machines, but also by way of SE Linux and SVirt providing those additional boundaries around the individual virtual machines. So any of those containers that are within those virtual machines have that additional layer of security as well. And then the common tooling. This is a big part of not only providing you with an easier learning curve for you don't have to learn different tools for the different tool sets, but also just from the standpoint of consistent look and feel between running OpenShift Container Platform and Red Hat Virtualization. For example, Red Hat CloudForms comes with OpenShift Container Platform, but it also provides a high level of integration with Red Hat Virtualization. Red Hat Virtualization 4.2 drops on Tuesday. You're going to find that it has a brand new UI built around the same pattern-fly engine that is used to create CloudForms. So you have a consistent look and feel there. And again, higher level of integration with that product. You can automate both OpenShift and Rev with Ansible. All of the roles and modules that you use to automate Rev are going to be included with Rev 4.2 and be completely supported. You can use those to automate OpenShift Container Platform. And then login metrics. The same EFK stack, Elasticsearch, FluentD, and Kibana that you use to monitor and log OpenShift. Come Tuesday, that ships with Red Hat Virtualization 4.2. So again, common tooling means streamlined operations, easier training, common look and feel for anyone that is looking to manage those environments and that common infrastructure. So this is one of the things that Jeff and Jason were talking about in terms of a common deployment. So you have at least you have your 3 master nodes, you have your 3 infrastructure nodes. Those 3 infrastructure nodes would be your routers, your registry, your load balancer, and then at least 2 or 3 application nodes, and of course you can grow those out from there. And then you have your operations team operating things there from existing automation tool sets, RESTful API, Ansible, so on and so forth, as well as CloudForms. And then do you want to check on the other demo here?
Let's see how our build has progressed, shall we?
Go ahead and pull your phones out again. Let's check this out.
So we're already logged into our OpenShift cluster. Let's take a look at our various components, assuming, of course, we haven't lost networking. Perhaps I spoke too soon. There we go. All right. So just to give you an example, these are the various OpenShift objects that were used to create the application, our little cat map that we're looking at. We have a build config, which kicks off a number of builds. 22 is the latest one I did just 11 minutes ago. There are image streams that are used to build the images, deployment controllers, replication controllers, routes, services, pods, all sorts of things. All of these components all work together. We have an outstanding tools team at Bandwidth. They put together a CI/CD platform built on Jenkins that automates a lot of this process and makes it possible for even an idiot like me to do a couple commands and literally redeploy our application. So let's toggle over now And we can see that our build has been completed. Took 2 minutes, 53 seconds. We'll look at our pods. And you'll notice that our latest pod is now this latest 19. If you recall, it was 18 on the previous version. So this is, in fact, a new version of our application. If we go to our application and reload it, well, maybe I didn't do the build right. Could have sworn it should say please. There we go. All right. So you see, that's just a very simple edit. Obviously, we're not going to reinvent the wheel here in a demo, but it is easy to do an upgrade on your application, redeploy it, and have it go live very quickly. So with that, if you would please, we're going to try out a new feature that we are only just now playing with. But if you would like to send another text message to that same number, but this time to MMS. Take a selfie, picture of your dinner last night, photograph of your dog, whatever you like. Grab that and send another message, and let's see what pops up on our map here. Uh-oh. Sorry, guys. There we go. So now we actually have multi-message, multimedia text coming in and being displayed on our map. Oh, someone listened to me and actually did send a picture of their dog. No, I'm sorry. My bad. Looked like, is it? Yes, it is a dog. All right.
Awesome.
You have a bigger screen than I do.
Great looking dog.
Anyway, just another example of bandwidth's capabilities. All right, and with that.
Yeah, and I'll also add the bottom link here is a reference architecture for OpenShift on Rev, and it's actually being updated as we speak. And then if you will come find me afterwards, we'll see if we can, there's one of the Rev PMs, well, actually all of the Rev PMs are here, and your question about how do you maintain consistency between CloudForms and Ansible, the short answer is CloudForms will help push the Ansible playbooks and roles out. And so it's not as complicated as you might think. But I can link you up with one of the Rev PMs that actually works on driving a lot of that integration work. So it's a fantastic question.
The Ansible, we use the Ansible installer to do all of our basic installation and upgrades. It's relatively automatic. You do have to take special care with your inventory. When you do an upgrade, say from 3.6 to 3.7, 3.7 to 3.9, you do have to make a few tweaks to your inventory file, but then you basically just run the installer and the rest is largely automatic.
And then just adding on to that, as far as upgrading Red Hat Virtualization, we just added in the Ansible automation for that as well, so you can have rolling upgrades for the clusters so that the virtual machines within a cluster will get evacuated from a host, pull down the update, apply the update, reboot the host, move to the next host, things get migrated over, so on and so forth until the cluster is completely updated without any disruption to users or workloads.
Yeah, and one more point on that. We use a method that I don't know if everyone does. So let's say we have an OpenShift cluster with 9 nodes, 3 master, 3 infra, 3 application. We actually have a 10th VM that we call the OCP installer. It's just a simple low resource RHEL installation, but it has all the OpenShift software installed, including Ansible and all the playbooks. We use that host to drive all of our installations. So sort of a host dedicated just to OpenShift, but that is basically our Ansible point of entry to doing all of our maintenance tasks.